Welcome all. In this lecture, we are going to learn about some rules for solving the block diagram. So let's start with the rule number 1, that is block diagram consisting of the block in the series connection, or it is also known as a cascade connection. So let's have a look at the block having the gain G1, and here is another block having the gain G2, and here is the output. These two blocks having the gain G1 and G2 are connected in series combination. This is the input A that is applied to the block G1, and the output of the block G1 that will become A into G1. This AG1 is being applied to the block G2. So after evaluation, the output of the block G2 will now become A G1 multiplied with this gain, that is G2. So the final output will now become AG1 into G2. So if you want to draw an equivalent block diagram of these two blocks that are connected in the series combination, then we can draw it just like this. This is the input, that is A, which is applied to this block having the gain G1 into G2, and finally we get an output that will be equals to A into G1 into G2. So this is nothing but an equivalent block diagram of this circuit. Let's move on to the next rule, that is blocks which are connected in parallel combination. So have a look at an example of two blocks which are connected in parallel. So this is the gain G1, and the output of gain G1 will be applied to the summer with positive polarity. This is an input A. Here is a takeoff point from which another block having the gain G2 is applied, and the output of the G2 is also being put into this summing point with positive polarity, and here is the final output that we will get. So let's evaluate the output, what we will get after solving it. So here A is applied, and here the gain is G1. So the output here will become A into G1. Similarly, A is applied and the gain is G2. So here the output will become AG2. Since AG1 and AG2 is now applied to this summing point, that's why in the output we get AG1 plus AG2. This is the final output that we will get if two or more blocks that are connected in parallel combination. Now if we want to plot or draw the equivalent circuit for this block diagram, then how we will going to draw it. So this is the input A which is applied. Here is the equivalent gain, and here is the output. Here we can write G1 plus G2, and in the output we will get a multiplication of input and this gain, that will be equals to A G1 plus G2. Now this A multiplied with G1 plus G2 can also be written as A G1 plus A G2. That will be equals to this term. So we can say that it is a perfect equivalent circuit of these two blocks that are connected in parallel combination. Let us discuss rule number 3, that is moving the takeoff point after the block. So have a look on a block diagram in which the input A is applied to the gain G and it is the output. Here is the one takeoff point and here the takeoff point output will also become this A because nothing is there in the path. That's why we will also get A here. And if we evaluate the output of this branch, then here the output will become the multiplication of input and this gain. So it will be equals to A into G only. Now if we want to shift this takeoff point after this block having the gain G, then what will happen? So according to the rule number 3, if we want to shift this takeoff point after the block, then the gain, that is G, will be divided and added inside this branch. So it will look like this. Here is the G, this is output, this is A. Now if we shift this takeoff point here, that will be at this point. So and another gain will get added. And this is nothing but a denominator part of this gain, that is 1 by G. This gain will come into denominator and then be added inside the branch which is shifted in the right hand side. And now here A is multiplied with G, so the output of this branch will now become A into G. Similarly, the output of this branch till here is A G, but if AG is being multiplied with 1 by G, then the gain will cancel out with each other, that is this G will cancel out with this G, and we finally get A in the output. Since the output of this branch, that is equals to AG, is same as this AG, and the output of the second branch, that is A, is same as this branch. That's why we can say that it is an equivalent circuit, or the moving of takeoff point after the block is being successful. Let us discuss rule number 4. So according to the rule number 4, this rule tells that what will happen if we move the takeoff point before the block. So let us take an example in which the input A is applied to the block having the gain G, and this is the output, that is equals to AG, and here is the takeoff point, and the output of this takeoff point will also be equals to multiplication of input and this gain, so it will also be equals to AG here. Now according to the rule, if we move this takeoff point before the block, then what will happen? So if we move the takeoff point before the block, then it will look like this. Here is the takeoff point that is being shifted before the block. Here the output of this branch will become AG. And if we shift the takeoff point before the block, then the side branch, that is the takeoff point associated branch, is having the gain of G. This gain is nothing but this gain before which the takeoff point is being shifted. And here again we get an output that is equals to multiplication of A and this branch G. So the output of first branch is equals to the output of this first branch, and the output of second branch is equals to the output of this branch. So we can say that rule number 4 is correct. Now, according to the rule number 5, what will happen if we move the summing point after the block? Now, let us have a look at an example. Here is the summing point. This is a 2-input summing point onto which an input A is applied with a positive polarity and another input B is also applied with positive polarity, and the output of the summing point is now applied to the block having the gain G, and this is the final output branch. Now let us calculate the final output. So here is the summing point. So here we get the sum of A and B signal. So here we get A plus B. This A plus B is now multiplied with this gain G. So what will we get in the output? That is nothing but a multiplication of this A plus B and this gain G. So it will be equals to G multiplied with A plus B. So we can also write it as AG plus BG. This is the overall output. Now if we shift the summing point after the block, then what will happen? So after shifting the summing point after the block, our circuit will look like this. Here is the A that is applied to a block having the gain G, and the multiplication of this block and the input will become AG having a positive polarity. And if we shift a summing point after a block, then the gain of the block will get multiplied with this branch. So here and another block having the gain G is being multiplied, and this is nothing but our input B. So the multiplication of B and G will become BG here, and we are applying the BG as an input to this summing point. So what will be the overall output? So the overall output will be nothing but a sum of AG plus BG. So it will become AG plus BG. Since the overall output of this circuit is exactly equals to the overall output of this circuit, that is nothing but AG plus BG. So this is all about the rule number 5. Now have a look at the rule number 6. So according to the rule number 6, we will discuss a condition that what will happen if we move the summing point before the block. So have a look at this circuit in which the input A is applied to the block having the gain G, and its output will now applied to the summing point, and this is the overall output. Here and another input, that is B, which is applied to this summing point, both with a positive polarity. So what will be the overall output? So here the input is given as multiplication of A and G, and the B is directly applied as an input to this summing point. So the output of this circuit will nothing but equals to the sum of AG and this B. So the output will become AG plus B. Now have a look at the condition in which we move the summing point before the block. So if we move the summing point before the block, then the summing point will be drawn first, and after this we will draw a block having the gain equals to G, and this is the overall output. Now we have to remember that if we bring a summing point before a block, then the gain will get divided and added inside this branch. So our circuit will look like this. Here is another gain, that is 1 over G, which is being added inside this branch, and this is the input B, and this is input A with a positive polarity. Now let's calculate the overall output of this circuit. So here the input, that is the multiplication of B and 1 over G, is applied to this block. So this will become B over G, and the input A is applied. Now it will become AG plus B in the final output. Since the output, that is AG plus B, is equals to this output, so we can say that this specifies the condition that if we move summing point before the block, then the output remains same and the gain will get divided. And in the previous rule we also studied that if we move the summing point after the block, then the gain will get multiplied. So we have to remember this thing. Now have a look at the rule number 7, that is interchanging of summing point. So we have to just discuss that what will happen if we interchange the summing point. So here is an input, that is A, applied to the summing point 1, and here is another conjugate summing point. See, this rule is only be applicable in case if there are two conjugate summing points. And here is the overall output. Here is another input, that is B, which is applied to the summing point first. This is positive polarity. Now what will be the output of this first summing point? So the output will nothing but the addition of this both signals, that is A plus B. Now this A plus B is applied as an input to this summing point with positive polarity, and here another input, that is C, is also being applied with negative polarity. So what will be the overall output? So the overall output will become A plus B minus C. Now just have a look in the case if we interchange this both summing point. So what will be the effect on the output if we interchange this summing point? Now let us draw this case also. So here is then input A, which is applied to this summing point. Since we have to interchange this summing point, so we will draw this second summing point firstly. Since the input C is applied to the second summing point with a negative polarity, that's why we will draw input C with negative polarity, and A is applied to the summing point first with a positive polarity. That's why here a positive sign will come. After this, what will be the output of this first summing point? So the output will nothing but equals to A minus C. Now have a look at the input of this summing point. So this summing point is nothing but a first summing point of this diagram, and to the first summing point and another input, that is B, is applied with positive polarity. So we have to apply an input B with positive polarity. So what will be the output of this block? Here is also a positive polarity. So the overall output will now become A minus C plus B. Now let us compare the both outputs. This is A plus B minus C, and this is nothing but same as A plus B minus C. Since the output of both the circuit is equal, that's why we have successfully interchanged both these summing points. Now let us discuss the last rule, that is splitting the summing points. Let's consider a circuit in which the 3 input is applied to this summing point. The input A and B is applied with a positive polarity, but the input C is applied with negative polarity, and the overall output will become A plus B minus C. Now in the case if we split the summing point, then what will happen? So we can also draw this figure like this, in which the input A is applied to this summing point. Since A is applied with positive polarity, that's why here also plus sign will come. After this, we consider another input, that is B with positive polarity, and the output of this summing point will fed into another summing point. Now have a look at the output of this summing point. So the output of this summing point is nothing but A plus B, and to this summing point and another input, that is C with negative polarity, is applied. So what will be the overall output? So the overall output will become A plus B minus C, that is A plus B minus C. So this is the output that we got in this both figures. So this is all about the concept by which we can easily split the summing point into 2 or more summing point. Thank you.